lesson is an introduction to scientific notation. It doesn't involve adding, subtracting, multiplying, or dividing numbers in scientific notation. It just introduces the concept of scientific notation and how to translate numbers between scientific notation and standard notation. All right. So scientific notation was created as a way to more easily write very large or very small numbers. A number in scientific notation is written as the product of two factors in the form a, the x means time, so it's not a variable x, it's a times, a times 10 to the nth power, where this n is an integer, so it's a positive or negative whole number, and the a value is greater than or equal to 1 and less than 10. And it's the absolute value of it. So the a value could be negative. So let's look at some examples here. So these are three numbers that are written in scientific notation. So 8.3 times 10 to the fifth. 8.3 is between 1 and 10. 5 is an integer. 4.12 times 10 to the 22nd. 7.1 times 10 to the negative fifth. All right, so this is what scientific notation looks like. So first thing you might be asked to do is determine if a number is correctly written in scientific notation. So this first one says 0.3 times 10 to the negative third. The answer is no on this because this number, 0.23, is less than 1. Is less than 1. And this number has to be 1 or less than 10. So it has to be from 1 to less than 10. So you can't have a number that's less than 1. All right, the next one, 2.3, that's between 1 and 10. That's good. Times 10 to the 7th, that's good. So this one is yes. Should have written no here. All right, the next one, the 9.3 is good. It's between 1 and 10. But this, so this is no, is not, I can't write today, sorry, is not 10. So this has to be 10. This has to be a power of 10. Okay? So let's go from scientific notation into standard form. So what does this number really represent? All right. Well, let's think about what it says. So I'm going to work this out, and then I'm going to show you an easier way of doing it. So this says 5.5 times 10 to the 6th. Okay, well, if we want to know what that is equal to, then can't we just do 5.5 times 10 to the 6 is a 1 followed by 6 zeros. 3, 4, 5, 6. So that's 5.5 times 1 million. So that would be 5,500,000. So that's the answer in standard form. So this number is supposed to be a shorter way of writing this number. All right, so I said I would show you a shortcut. So here's the shortcut. Write this here, shortcut. Take this decimal point and move it 6 places to the right. So if I take this decimal point and move it 6 places to the right, okay, so I'm going to write the 5 and the 5. So it was here, I moved it 1 place. Now I need to move it 5 more places. So 1, 2, 3, 4, 5. So the decimal point was here. I went 1, 2, 3, 4, 5, 6. I moved it to here, right? And we end up with the same answer that we got by doing 5.5 times 1 million. All right, so that's the shortcut. The exponent tells you how many places to move the decimal point. Okay, well, what if the exponent is negative? All right, so let me show you what this is the long way, right? So the long way, 10 to the negative 4th, if if you haven't learned about negative exponents, to make that a positive exponent, you would put it under 1. So that's 3 times 1 over 10 to the 4th, which is the same thing as 3.1 divided by a 1 with 4 zeros. So 3.1 divided by 10,000. So if I take 3.1 divided by 10,000, I'll get 3, 4. I think I did this right. 1, 2, 3, 4. Yep, I'll get this number. So 3.1 times 10 to the negative 4th is equal to 0.00031 in standard form. Okay, so is there a shortcut for that one? Well, of course there is. So the shortcut, if there's a negative exponent, you can do the same thing moving the decimal point, but you're going to move it to the left. So we're going to move it 4 places to the left. So here's a quick trick for that. So see this number 4, that's the exponent. If you just write down that many zeros, 1, 2, 3, 4, and then write down the 3 and the 1, and put your decimal point right there between the first 2 zeros, it'll give you the answer. So the decimal point was here, and I moved it 1, 2, 3, 4. All right, so let's do these last 2 using the shortcut. So positive exponent of 7, so I'm going to move the decimal point 7 places to the left. So 1, 2, and I need to move it 5 more places, so I'm going to add 5 zeros. So 5, 2, 3, that moved it 2 places, right? It was here, I went 1, 2. I got 5 more to go, so I'm going to add 5 zeros. 3, 4, 5. Add some commas in here so I can see the place values a little easier. And I get, oh, my phone's ringing. Hold on, I'll be right back. Sorry, when the boss calls, you got to pause it and answer the phone. All right, so we moved the decimal point 7 places to the right, gave us that number. All right, so a negative exponent, we'll do the same thing, but we're going to move the decimal point 4 places to the left. And so again, the trick I said was if you'll just write 4 zeros, 1, 2, 3, 4, and then the numbers 2, 0, 9, make sure you write all these numbers, and then put the decimal point between the first 2 zeros, it'll give you the right answer. And so again, you can check it. The decimal point was here. We needed to move it 4 places. 1, 2, 3, 4. All right, so that's scientific notation to standard notation. So let's look at going the other way. All right, so what you want to do is move the decimal point until you have a number A. Remember that value A has to be greater than or equal to 1 and less than 10. So let's look at, let me change colors here. Let's look at this one. Now remember, the decimal point's right here. We don't write it, but it's there. I need to move the decimal point until I get a number that's greater than or equal to 1 and less than 10. So I'm going to move the decimal point to here. So the decimal point is going from here to here. And how many places did I move the decimal point? I moved it 3, 6, 9. So I take this number, 1.43, I drop all those zeros, times 10, and now is it 10 to the 9th or 10 to the negative 9th? Well, think about it. To get the decimal point back to its original place, it would have to be moved to the right 9 places. So that means this is a positive 9. Positive exponents give you big numbers. Negative exponents give you big decimal numbers like C and D. All right, so that's the answer. That's written in scientific notation. This number is greater than or equal to 1 and less than 10. This is the power of 10 with an exponent. All right, so let's look at this next one. So I move the decimal point. I'm going to move it to right there. So how many places did I move it? I moved it 3, 4, 5 places. So this would be 6.78 times 10 to the 5th. All right, now we're going to go the other way. So on this one, I'm going to move the decimal point from here to here. That gives me the number 3.2, which is greater than or equal to 1 and less than 10. And then I'm going to count how many places I moved it. 1, 2, 3, 4, 5, 6. And this time, it's 10 to the negative 6. So again, positive exponents give you big values. Negative exponents give you really small values or big decimal numbers. All right, last one. So on this one, I need to move the decimal point to right here to create the number 7. A lot of times my students will move it here, and then you end up with 0.7. That's too small. So it's got to be a number greater than or equal to 1 and less than 10. Then count how many places I move the decimal point. 1, 2, 3, 4, 5, 6. So it's 7 times 10 to the negative 6. All right, so that's all there is to it. So I hope that was helpful for you. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.